All right, guys. So this is like what part seven. We're almost through this. So if you're doing all this work, thank you so much because you're trying to get better, and I can always appreciate that. So here at page eight, again, I'm going to do this kind of here by mouse pad. So I won't be able to write a whole bunch, but at least I can kind of show you the pieces. And again, I'm going to leave the why does this actually work kind of stuff up to you, but I'm going to help you identify what to actually do. So, in Scribe Square, well, I mean, this is no secret. Like, we're going to start with points. Like, if you haven't noticed, like, the one theme for this entire semester so far, let me clue you in. It's all about points. So, let's say I want to draw this Inscribe Square. And again, what Inscribe means is that I have this circle, and the square I'm drawing has to exist. All the vertices have to exist on the, excuse me, on the circumference of the circle. So the square has to kind of run through kind of in this area, this configuration. So the important thing to note here is that we can kind of play with this. First, to kind of get a sense of how I have to build this, and then we'll actually build it. So we need 4 points. You know, it's a square, so 4 points are going to be mandatory, and they ought to be on the circumference. And so if you're looking like this is roughly probably where those 4 points are going to end up. You can probably tell right away that this needs to go just slightly higher. And this maybe moves slightly to the left and slightly to the right because they have to be evenly spaced. Now, for a square, if you kind of consider what it means to space out evenly 4 points, you're actually creating some very important structures on the square itself. Like, for example, if I take this point and run it across to this point, I can conjecture like this should probably travel right through the middle. And again, that's probably a bit high, so I can move it down a little bit, which is validating more that this just runs right through the middle. And that's something I can totally do over here. So I can take a line and I can run it, boom, right through the middle. Right? I'm actually halfway through my square because I located 2 points already. One right here and then one right here. So I got 2 out of the 4 I need. Now I just need to figure out these other 2. Well, if I have this line to begin with, which located 2 of my points, what I have to kind of think about is these 2 points, top and bottom. Like, how do they relate to each other? How do they relate to the line? Well, hopefully you're seeing that these 2 points have to be one on top of the other. Listen very carefully. One on top of the other on either side of the line. That is totally like something I've done before. Let me go back and find a previous page here. No, not this one. Oh, here we go. This is the one I'm looking for. So that you mean I need 2 points, like one here and one here, on either side of the line, one on top of the other. That means I need to make a perpendicular bisector. It's again a previous construction that I know to be true. I'm going to be using again because a perpendicular bisector goes right through the middle of a line in a perpendicular manner and produces 2 points symmetrically, one on top of the other. That's what I have to do for this one. Oop, too far back here. So I have to make a perpendicular bisector of this. So like very roughly sketched out. I need, ooh, I don't want that. Okay. I need this line. So it's a right angle and perpendicular like this, okay? So the way I'm going to do that is probably by using those circles again. So let me kind of get a circle construction here. A little lighter. So I'm going to pull this out, and it doesn't really matter where I get it. I know I have to go farther than here. It does, but I don't necessarily have to like hit it perfectly at the top or bottom of that. I'm just going to pull it out. Maybe it's about right here. Okay. Now the important thing is I'm using the same exact circle. I'm going to cheat a little bit and use copy paste, but it's just about sketching that circle and getting it to center right here, which I think about. Oh, I kind of lost my center point. Hold on. There we go. Okay. So now I have these 2 points, top and bottom. Okay. So now between these 2 points, I can totally construct a line. Now, I know what you're saying. This line does not go all the way through. I totally understand that. It does not go all the way through, but I can always extend it. So like I can extend it down this end, and I can extend down this end because lines do extend in both directions towards infinity. And now that's provided me with my next 2 points, my last two, or my next 2 points. So I have one here, and I have one here where it intersects. That should be able to, I now should be able to produce my square, which I'll do in red. Oh, I just opened iMovie on accident. It's about to pop up. I can't force quit. There it goes. Okay. Um, sorry about that. Anyway, so I totally should have my square. I'm going to draw it out in red, these 4 points. All right. So just really quick recap. I was kind of rough sketching over here to decide what kind of construction I needed. I need 4 points spread evenly across a circle, so I started with a diameter, and then I use a perpendicular bisector down to the middle to find these two, and now I have my square. Okay, regular hexagon time. Now this one's going to get messy. I'm going to kind of warn you ahead of time. But if you think about a hexagon and how I'm going to kind of construct it, what I need is some points. So probably 6 evenly spaced points in a roughly circular pattern. Okay, which would give me my hexagon. Now for this one, I actually need a 7th point right in the middle, which has actually been provided. So if you think about what kind of construction you're seeing or what kind of structure you're seeing, hopefully you're picking up on this fact that I have some equilateral triangles here, which I totally know how to make. We talked about it even in an opener, I think, pretty recently, but it was also in your super packets. Oops. Okay, so it seems to me the structure I need are equilateral triangles, because that's the case here. Now, if you think about equilateral, some things to pick up on is that these are actually a bunch of radii. So if I do have this circle that's going to encompass all these points, then this value that I'm currently holding, this red line, is actually a radius. And that means that that's a radius, and since it's equilateral, that's a radius too. So what it seems that I need are some circles. So let me load up these circles, and I'll show you what I mean. So if I have this circle, um, and I want the radius out to my circumference, this distance from here to here has now actually defined a radius. If I start at the intersection point and drag another, I've actually now created an equilateral triangle. Allow me to show you. Actually, let's change color. Okay. So from center to intersection and back, that is my equilateral triangle. Now I just need to replicate that. That's a really terrible color choice. Let's go with that one. So from here to there to that intersection and back is my equilateral triangle, and you actually can see it right here as well. There's my second one. And so you're actually starting to see the hexagon form. You have one line here, and one line here. Now I can keep following this around because that's my second one, but I'm going to need some more circles. So let me switch back to my circle tool and keep going. So I need some more radii, and some more radii, and some more radii. Now I probably had it even before that step, but I also want to take this opportunity to kind of remind you that we've seen this construction before. In fact, it's probably the first thing I asked you to do. It's what I call that geometric flower. But again, you see these equilateral triangles starting to form. And so we now should be able to fill this in. Okay, so we have the equilateral triangles, which I'm not going to necessarily all draw in. When I connect them, you see that I have this nice hexagon pattern. Now, I also want to point out that this should also be similar for the triangle. So if you look at, let me change colors here. If you look at the spacing here, the only difference between the hexagon and the triangle is I'm just kind of skipping points. So this is actually a dual construction. You can actually extract the equilateral triangle out of it, which is what I'm going to do in the space below. So it's the same exact reasoning as this. In fact, I'm going to take this whole thing and just copy paste it. Okay, so it's almost the exact same construction. The only difference being instead of having the full-on hexagon, I'm going to skip every other point. Let's go blue. And then I have a nice equilateral triangle. So again, almost exactly the same as a hexagon, just skipping points. Okay, so that is page 7. One more page to go, and we are done. So a little bit different constructions here. It's kind of all based on this idea of equilateral triangle and how it can expand over the course of an being inscribed inside a triangle. But thank you for watching this, and